Hello, my awesome students. I realized today I got the same question a lot of the time over and over after doing a review, and so I wanted to take the opportunity to make a quick little video to explain something that I hope will clear up a lot of the questions that I got today. Now, today in some of my classes, I did this mostly in the morning. I didn't do it in the afternoon because I really decided that it was just kind of making things a little bit more confusing, and so I want to come back and explain a little bit more for those people, but then also for the afternoon, because I feel like this will explain a lot of the questions I had. So here was the main question I got over and over. As we were looking at drawing warm and cold fronts today in the United States, in that little example that I gave a lot of you guys, I got a lot of the same questions, and that is right here in this pattern. You can even see it right here on this actual data website. How do we transition from having this warm front here to all of a sudden having just a cold front? How does it switch like that? And you can even see it down here in this part of my screen where we, again, have this warm front all of a sudden transition into a cold front. Not only that, the warm front is heading north while the cold front is heading just more in an east direction. So why does that happen? That has to do actually with these low pressure systems. Apologies. If you come over here and look at what's actually going on at Earth Not Null School, let's actually look at some of the wind patterns and look at how the winds are moving in this area, and will also help hopefully explain how these occluded fronts happen. So let's come over here. Now this little green dot is actually right where that low pressure system is on this one, more or less. Move it just a little bit, or here. I think this is actually what I was intending to do. So that little green dot is more or less right where that low pressure system is. Look at the wind patterns that you see here. If you notice, it's not just quite exactly as static as I was making it sound, where it's just all blowing one way. Rather, around low pressure systems rotate in the northern hemisphere counterclockwise. The result is that all of this cool air, especially this cool air that you see up here by Greenland, where it's just freezing, all of this cold air eventually gets pulled in and it's pulled down and it just swirls around this low pressure system. Well, it cuts the other way as well, where this warm air down here by the equator is pulled up towards the low pressure system. So you got these two competing temperature areas where you have cold in the north and warm in the south that end up getting swirled together. This is ultimately what's going to form our fronts. Let's look at this. Right here, you can even tell there's some sort of little barrier, something going on between these two winds where they suddenly change direction. Well, let's look at the temperature on one side of this line, and the line I'm referring to, if you can't see it, is this line right here. Let's look at the temperatures on either side of that line. Over here, we have, and look at these temperatures over here on this side. Over here we have 45, 44, 45 again, 46, mid-40s pretty much uniform all throughout here. I think if I go back here, it does get a little bit colder. We get high 30s. Well, let's look on the other side of this line. And again, this is where it says there's actually a cold front. So if I have mid-40s over here, I should have something warmer on this side. So let's actually see what we got. So again, mid-40s. Right when I cross that line, mid-50s to low 50s. Right? This is cold air, and you can even see it graphically, being slammed into warm air. That, by definition, is a cold front. That as this air swirls in, it makes a cold front because that is where you have these two temperature differences. Well, up here in the north, we have this warm front. Warm fronts, by definition, are the exact opposite, where now we have this warm air being swirled up into this cold air. So this air up here by Iceland should be colder than the air I have down here. So let's go and look. So again, down here we have our, especially if we go a little bit higher, albeit it goes lower 50s, but all the same. So mid 50s to lower 50s. But then when I head up to here, where that air is being moved to. Now I got low 40s, high 30s up here where that warm front is at. This same pattern happens everywhere in the northern hemisphere because of these rotations that go on at low pressure systems. They rotate cold air down and they rotate warm air up. So you get warm fronts up high, cold fronts down below. And it's really cool. You can actually even just see this just when you turn on just looking at clouds. When you look at clouds, you can see right where these fronts are at. You see this warm front there, this cold front right here. And then up here you see this warm front, this steady little band up there. So anywhere else that we look, we're going to see the same little pattern. There is this example here, but I'm going to hopefully see, oh good, it is actually moving. I want to come over here and show you something else. Here across the United States, as you see, there's some stationary fronts, there's some other cold fronts. There's a lot of weird things that go on over the continental United States. So we're not going to pay too much attention to that. We're just going to focus on just the simple examples. And right over here, we have another just classic example of warm front moving up to the north, cold front moving to the east. If I go in Earth.NullSkull over to that same location, which is over by Alaska, and even in the clouds, you can start to see that same shape already take place. Here's my rotation for my low pressure. Here's my cold front. Here's my warm front. I should have colder temperatures here. Let me actually turn it on to temperature. There we go. Colder temperatures right now being defined as 41, high 30s, right over here, 45, 44. Considerably warmer. And then if up here where I have my warm front, these should be colder than what I have down here. So again, down here, 46. Then if I move up to where that warm front was, mid-30s. Okay. Again, I hope that this was helpful in understanding how these cold and warm fronts actually form. I did just remember I said I would explain briefly how these occluded fronts form. Remember, occluded front is formed when a cold front runs into a warm front. And it's still explained the same way, where because we have this rotation, these cold fronts move a lot faster. And as they do, they kind of end up swallowing these warm fronts, making an occluded front. On either side of the occluded front, because we've all moved all the warm air up into the atmosphere, pretty much all these temperatures should be about the same. So if I go into here, all of these temperatures over here should be pretty much about the same. 36, 38, 35, so 3 degrees, 4 degrees difference, if that, not really big of a difference. That's right where the occluded front is at, and that's pretty much the end of the storm. Okay, I hope that this helped. Please email me, come talk to me after class, or whatever else you need to do if you need any more little explanations of this. But in the meantime, again, I hope this makes sense. Thanks, you're all awesome.